Okay, I had another question from page 233, and the question says to write the function f of x in the form x minus k times some q of x plus r, and f of k equals r. So prove f of k does equal r. So here's the original equation. F of x equals this equation, and the k is -2. So if I look to the form they want me to put it in, can you see that it would look like this? F of x equals x minus k. So k is -2. So x minus k would be x minus -2, or x plus 2, times some q of x, which is a different equation than f of x, plus some r that is probably the remainder. So how do I get this q of x? How do I get that? Well, this obviously times q of x equals this equation here in f of x. So if I divide this into this, I could get the q of x. And if it doesn't divide evenly, then the remainder would get to be put here. Well, we can do that. We can use synthetic. So if I were to use synthetic with x plus 2, do you know what I put here? -2. What do I put across here? These coefficients, right? If I divide this, then I'm going to get a polynomial with 1 degree less, correct? So let's do the division and see what we get. Going down the first number 1, -2 times 1, -2, -7, 2 times -7, +14, add, I get 3, multiply, -6, what do I get here for the remainder? 2. All right, so let's write this now as a polynomial. So I have to put the x's back in. Remember, when I divide, I decrease the degree by 1. So if this is x to the third, this is x to the second. So I have 1x to the second minus 7x plus 3 plus a remainder of 2. We'll just put plus 2 there. That's the remainder. Now, this is the q of x. So I can write this equation in that form. I can write it by going, let's see, f of x equals the x minus k we already figured out was x plus 2. And then now we know that the q of x, I'll just write that here too, q of x equals that, so x squared minus 7x plus 3, there's the q of x, plus the remainder at the end, which this time is 2. So now I have the equation in the form they told me to write. Now, the question also said that prove that that is the remainder, right? Or prove that f of k equals r. So we found out that r equals 2, right? So now we need to prove that f of k equals 2. So f of k means to do f of -2, and I have to prove that that equals 2. Now, how can I prove that? I could just plug 2 into this equation. In other words, I could do f of 2, f of -2 equals -2 to the third minus 5 times -2 squared minus 11 times -2 plus 8. And use your trusty old calculator to figure that out, and you get f of -2 equals 2. So that is pretty cool. In fact, what that is telling you is whenever you have any function and you want to plug in a number for the variable for that function, the answer for plugging in that number is always the remainder that you get when you use synthetic with that number. And that is a great time-saving way to solve problems, especially if you're doing the SAT and you need to plug something in. You've got exponents, and it's far quicker. In fact, we could have a little race one day in class of you plugging in the -2 and me doing synthetic to get the answer. And I bet you I can win. All right, there you go.